I'm going to solve the third problem of the final exam of electricity and magnetism that says like this. When a 40-volt EMF device is placed across two resistors in series, a current of 10 amperes flows through each resistor when the same EMF device is placed across the same two resistors in parallel. Here, the current through the EMS device is 50 amperes. What is the magnitude of the larger of the two resistors? So here we can determine that as they are in series, our difference of voltage will be equal to the current 1 times the sum of our resistance. But here, as they are in parallel, they have to be in the inverse. So the difference in the voltage is equal to the current 2 times 1 over R1 plus 1 over R2, and this the inverse, okay? But this is equal to saying that the difference in the voltage is equal to the current in 2 times the resistance 1 times the resistance 2 over the resistance 1 plus the resistance 2. Okay, this is the same. So as we determine here the difference of the voltage, and here the difference of the voltage, we can then determine here we can get out of the equation the resistance 2. That the resistance 2 is equal to the difference of the voltage over the current in 1 minus the resistance 1, because this one passes to the other side with a minus sign. Okay, once we have determined this one, we are gonna use this specific part in here and this specific part in here to determine the difference of voltage. So we're gonna multiply them, and as we multiply them, first of all, before multiplying here, we're gonna determine a formula, an equation for the difference in voltage. In here, the difference in voltage corresponding the current in 1. Here, the current in 1. Okay, so the difference in voltage over the current in 1 will be only equal to the sum of 1 plus the sum of 2. Okay, and here for determining here the same difference of the voltage respect to the current in 2, here we are only gonna have this multiplication over this sum. Okay, and then we can multiply both differences in order to have an answer of the difference of the voltage. So the difference of the voltage squared over the current in 1 times the current in 2 will be equal to this first one, the resistance in 1 plus the resistance in 2, times all this part, resistance 1 times resistance 2 over resistance 1 plus resistance 2. Okay, and once we determine this will be equal, with pure algebra, this will be equal to the resistance 1 times the resistance 2, because these two gets cancelled, so this one is the one we are leaving here, and this will be equal to the resistance 1 times the difference in voltage over the current 1 minus resistance 1, because the resistance 2 was the one we determined in here. So this one is the one we placed inside this parenthesis. Okay, once we determined this relation, then we can determine that the same difference of the voltage square over both currents is equal to the difference in the voltage over the current in one times the resistance in one minus the resistance in one square. That is this same part in here, okay? And this will be according to the resistance in one. This will be equal to the resistance in one square minus, and here we will obtain the difference in the voltage over our current one, and here we will have times our resistance 1 plus, and here we will have this part in here, the difference voltage square over resistance 1 times over current 1 times current 2, okay? And this will be equal to 0 because it is in equilibrium. So this part in here can be substituted with the values we are given by the problem. So here we know that the difference in voltage first is 40 and the current in one is 10. So this is equal to 4, okay? And then here we are given that the difference in voltage is 40, so it's 40 squared, and here we know that it's 10 times, and we know that the current in 2 is equal to 50. So this is equal to 3.2, okay? So we are using these values, and the only variable that it's missing is the resistance in one. So that's how we are gonna determine the values for R1, and we're gonna determine which of the two resistance is the larger. Okay? Once we have that, we can rewrite our equation as the resistance in 2 squared minus 4 resistance in 1 plus 3.2 equals to 0, okay? And once we solve this equation in here, we can find that the values for R1 are equal to 2.894 ohms or 1.105 ohms, okay? If we use this value in our formula for the R2, that was 40 minus 40, this one, the difference in voltage over the current one minus the resistance 1 minus our resistance 1. This will be equal to 1.106 ohms, okay? But if we use this value in here, we will obtain a value of 2.895, okay, ohms. But we want to determine here, as we know here, as we see here in our parallel structure, we know that the resistance 1 is bigger than the resistance 2. So here the resistance 1 will use this value of 2.894, and for the resistance 2, so we're going to use this value of here. And this is how you solve this problem.